Thank you for having us in this session. I'm Guy Korland. I'm the CTO of Incubation in Redis. And with me, okay, I'll present you. Ed is the Senior Product Manager and responsible for our AI machine learning initiatives in Redis. Ed will run the slides and then we'll join and present the second part of it, and we'll show you what can you do with Redis. Thank you, Ed. Switch, please. So what are we going to talk about? We're going to talk about why using Redis as your real-time online feature store. Ed? So I guess most of you or all of you are already familiar with Redis. Redis is an open source in-memory data structure store. Mostly uses cache. I guess most of you know it as the default go-to cache solution or as a message broker. But Redis is more than that. Redis is being used lately as a database. It's been used so much as a database. It's so loved because of its simplicity that it was picked in the last 5 years as the most loved database by the Stack Overflow community. 5 years in a row. Okay. More than that, like Redis is being downloaded by the billions. It's the most downloaded pulled database on Docker Hub, more than billion. In fact, it's more like 4 or 5 billion. Like Docker Hub just don't show you the number, but it is being downloaded by millions every day as the most loved and most used in-memory database. Okay. But a bit about us, like we are Redis, the company Redis, the company behind Redis, the open source. We are, as we said, the home of Redis. We are developing, maintaining, extending, and contributing to Redis in general and every ecosystem or many ecosystem products around Redis, the clients. And in general, we are keeping the Redis community happy and alive. We are really welcoming every open source contribution. This is a very open community. But obviously, the company is also having its own commercial version called Redis Enterprise. It's like, and I'll you know what, I'll cover it later in the next slide. But we also offer an hosted solution for Redis. So like, click your own, like, click and get your own Redis offered on every major cloud, Azure, AWS, GCP. And we are already have like more than 8,000 paying customers across the globe using our product on the cloud, on-premise, Redis Enterprise. Ed? But what is Redis? Like, let me go deep a bit about Redis and explain you more about what is Redis and what is more than like why we call it a database. Like Redis, as you know, it's probably what you see on the left. Like it's different data structure. You can store very nice different data structure, like about 10 different data structures, strings, set, hash, bitmaps, lists, even interesting data structures like streams and hyperloglog. But it's more than that. You can use Redis using these modules on the right. These are like extensions that you can deploy on Redis. Also being maintained as a source available. You can go on GitHub, see the source, play with it, contribute, open issues, also manage as an open community. And this way you can get much more from Redis than you might expect from Redis as a simple key value. You can store JSON, documents, like you might store on every big data solution. You can even index them using some Redis search, doing some secondary, full text search, numeric, geoinformation. You can even store graphs, full graph database, like you might expect from any database, time series database. The nice thing that we are also focused on is how you can enhance your logic by shifting your business logic into Redis. This way you can even get much better performance with using gears, or even more probabilistic data structure like Bloom filter, Cuckoo filter, and many more. But on top of that, we are providing as a company, this is the commercial product that I described before, the Redis Enterprise. Redis Enterprise is what you would expect from any enterprise product, probably, when you want to take the open source experience and start to deploy it in production, or stop care about all the management tools. So you'll get automatic linear scalability, high availability, durability of your database, obviously some backup and restore capabilities. And the thing that we're most proud about is you can do geo distribution. You can really have like 2 sites far away, fully replicated, and active and doing some self conflict resolution. On top of that, you will get all the other stuff that you might expect from any database, like multi-tenant or security. But I think if you like take one step back, if we are seeing this pattern, like if in like 20 years ago, the most adopted database, what everyone would expect from a database was a relational database, and obviously Oracle, IBM, Microsoft were the leader back then. Then like 10 years ago, with the boom of NoSQL and all the other solutions, you would have seen like MongoDB, CouchDB, even Elasticsearch, Cassandra. You will see all these NoSQL database, document database popping out. We believe that in here, like in these 10 upcoming years, you will see this boom of open like Redis in-memory database solutions, because you do need to provide a low latency solution for your user. You need a real-time experience. And this is why we are here. We are talking about real-time experience, and this is where we think Redis is shining and almost the only one who can provide this low latency solution. And why do you need this low latency, such a low latency solution? Ed? So today, everyone expects like a real-time interaction. They expect like a constant experience, less than 100 millisecond experience. You expect to go to this website or open your application and feel a smooth experience, an instant experience, less than, and the numbers are talking about less than 100 milliseconds. And we're talking about everything, including AI, including like real-time inference. When you have a user interactive application, the user need to feel a smooth experience, even if you have a huge amount of business logic running behind it. Even if you push a lot of data into your application, you want this data to be pushed to your client almost instantly. Okay? And for that, you need a database that can interact with your application or ingest data in a sub-millisecond experience. So even if you already, like for example in AI, you already trained your model to be very, very fast, and it takes like half a millisecond to do the inference or to react on the user interaction. If your database does not react in a less than a millisecond, you're probably not going to be able to provide your end user the less than 100 millisecond experience, because usually your application will interact with the database a couple of times. You also have the internet latency between the user and the application. So summing it all together, you need your database to be very, very fast, less than 1 millisecond. If you're going to use this traditional database that provide you like 10, 20, 30 millisecond latency, you probably won't be able to provide this less than 1 millisecond latency to the end user. And the whole user experience will be damaged. So for that, you need to make sure that the data interaction, even with your model, with your application, everything is kept below 1 millisecond. And this is why, Ed? Oh, thanks. And this is why we think Redis is the most suitable database for online feature store. Like when you need your inference to be low latency, when you need your inference to be real time, like for example, user interaction, maybe video processing, everything that needs some low latency inference that includes some data that you need to take your model, that grab some data and do some low latency inference, then you must have this low latency database. So Redis is there for, is amazingly suitable for that, doing low latency inference and high throughput. And it comes with extra capabilities that might help you do this inference in a better way. For example, it comes with a data structure called stream. So like you might do in other platform, you do some stream processing, you can now do it in Redis. So you can use Redis stream, do this low latency inference and stream processing, and immediately store it into your online feature store and immediately use it into your models. So everything resides in the same thing in memory, does not move between infrastructure that don't move between database. So you can really go into this sub-millisecond latency. On top of that, as I said before, you have other data structures. So maybe you need for your model or for your online inference a more complex data structures. So you have all of them there. You can put a time series data. So you can do like maybe you want to retrieve a data that scale for the last hour or something like that. So you can retrieve it from the Redis time series in memory again and do the inference. Maybe you need a graph data. Maybe you need to crawl some graph and retrieve this data and run it into your model all very, very fast in real time. On top of that, and that's the last point I want to cover, is that Redis is scalable. Redis by design is very, very scalable. It can automatically shard, scale out, and let you store more data and utilize more CPUs. If you think that even this hundreds of thousands of operations per second that the single Redis process can do is not enough, then you can easily scale out and process more data much faster. With that, I'm going to hand it over to Ed, and he'll cover like examples. Go ahead.
Excellent, thanks, Guy. So yeah, so before we explore into more details of how those technical capabilities are used by multiple companies and that have adopted Redis for their online feature store, I want to take a step back and actually look at some of the companies, the use cases, and the common requirements and challenges that we've seen with companies like this, and some of the partnerships that Redis has forged along the way. And in particular, I want to focus in 2021, the last year. And then in my second part of the presentation, I'll focus on some of the key trends or insights that we're seeing based on what we discussed and what we saw in 2021. So if I take your mind back to late 2020, we're 6 months into the pandemic, but at that time, DoorDash publishes one of the first blog posts that cites Redis as an important part of their low latency feature serving infrastructure. And this is important. I'm going to dedicate a little bit more time to their use case later on in this presentation, but some of the challenges and key requirements that they have are as important today as they were back then. Then in April, Redis runs this annual event called RedisConf. And at that event, we position Redis as, we saw two key use cases or AI and ML workloads where Redis could play a fundamental role. One is Redis as an online feature store, and the second, Redis as a vector similarity or embedding store database. For the purposes of this talk, I'll just focus on the online feature store aspect. But I can take questions around our vector similarity search capabilities if that is of interest. But looking at around about that time, we started noticing a number of companies with their engineering departments publishing blog posts or presenting on YouTube and conferences. And all these companies were building their online feature store using Redis. And when you look at this, this group of companies, most of them are familiar for our US audience, but I want to call out a couple of companies that you may not be that familiar. Zomato and Swiggy. So these guys are giants of food ordering and food delivery. Swiggy operates in India and they serve 500 cities over there. And Zomato operates in 24 countries and serving more than 10,000 cities. So you can think of them as your online food order delivery giants there. So one common pattern across all of these companies is that they saw increased demand during the pandemic, right? So we all order more food, that food need to be transported, interaction, we watch more media, we increase our use of telecommunication services and found even services that we didn't know existed. So one of the less kind of obvious pattern in this group of companies is that not only they were using Redis in their online feature store, but also they were leveraging Feast, the open source project, as part of their feature store implementation. So this led Redis to collaborate, establish an ongoing collaboration with Feast. And since kind of July timeframe, we've contributed, our Redis engineering department has collaborated code into the Feast project that has improved Feast performance. Later in the year, we came across another interesting use case, and this time is another Indian company called Udan. You can think of them as a kind of B2B enabling platform. They connect millions and hundreds of millions of small businesses in India to other businesses or to end users. Not only they provide the platform and technology, but also the logistics and the capital to fund and facilitate transactions between these small, medium businesses and consumers. One of the interesting aspects when they shared their approach to feature stores is that they wanted to deploy Feast on Azure. They have a big partnership with them. In parallel, Redis was also collaborating, and we have a long-standing engineering collaboration with Microsoft. Some of our Redis Enterprise offering are actually first-party services within Microsoft, and that collaboration led culminated into Microsoft publishing how to deploy Feast on Azure. And for those of you interested, that you can check out this GitHub. Super interesting approach to deploy Feast using Kubernetes on Azure machine learning, and having the host of Azure machine learning services ready to use with Feast. Then later in October, Uber, the original kind of project when it comes to feature stores, they also reported using Redis for some of the feature stores, feature sets that they store. I'll talk a little bit more in detail in the next part of the call. But this was super important for us, kind of validated some of these capabilities. And lately, as late as last week, as I was preparing the slides for this presentation, Feast surprised us with publishing a benchmark on their online feature serving capabilities. So they compare AWS DynamoDB, GCP Cloud Data Store, and Redis open source. And I invite you to take a look at their detailed report. So with that in mind, I wanted to focus on 3 use cases that I think are very reflective of many of the key challenges and requirements in online machine learning predictive applications. So let's start with DoorDash, because as I mentioned, they were one of the first ones to publish a blog post citing Redis. And I wanted to run you through some of the key requirements that they mentioned. So as you may expect, these guys use machine learning in many different places. One of their key use cases is what they call store ranking, which is, you can think of it as personalized consumed search result. And when you think that they have millions of consumers with millions of merchants and millions of menu items in a store, they need a low latency and persistent storage for billions of records. Not only that, when you think of the store ranking use case, they generate millions of predictions per second. So that is extremely high throughput. Also, another key requirement that they had was the ability to do real-time feature aggregation. So this is the ability to listen to a stream of events, aggregate them into feature, store them into the online store, and consistently moving that data back to offline store as needed. This is super important when it comes to online machine learning applications, that having access to that fresh stream of events and convert that into features. Another key requirement is the ability to do fast batch writes. As you are familiar, online features are typically refreshed periodically. Some of them, some of the customers that we've seen, they refresh daily, and some others even twice a day or hourly. So, but when that happens, all of those features are materialized or written to the online store in batch, and that is a process that needs to happen fast. Another important requirement for DoorDash was the flexibility of dealing with heterogeneous data types. For them, features could be stored as a string, as numeric floats, could be list, or it could be a bunch of embeddings that are already are stored serialized as and ready for consumption for inference. And they found that flexibility in Redis. And not only that, I think in the quote that you can see on the right-hand side, you can see that they benchmark a bunch of key value store options, and they found Redis was the best. And for not only for low latency, but once they decided that, they invested additional engineering cycles to optimize their storage and serialization and compression of these features. And that led to a tripling of their cost reduction. Not only they achieved their requirements, but also they reduced their cost. And high availability and scalability is super important for them too. So moving on to AT&T, as you can see, their use case is fraud detection. And this is kind of the quintessential use case in financial services and increasingly in other industries. What I found super interesting for fraud detection, and particularly the AT&T approach, is that their models use real-time features as the majority of their the features. So when you look at the number of features that they have offline versus the one that they calculate online, is already a 1 to 4. And why is this important for fraud detection? Well, as you can expect, if you're just about to make a decision on a transaction, the value and the behavior that is encoded in real-time features is more important than features that don't change through time that much. If I'm about to commit fraud, probably chances are that there are a series of transactions happening at the same time that exhibit some form of unusual pattern. And the ability of monitoring real-time events, aggregate them, and turn them into features is important for fraud detection. And it was super important for AT&T. You can watch, so on the link on the right, you can watch the entire presentation covering their end-to-end machine learning platform that goes all the way from model training to deploying and serve and monitoring. But I thought what I found interesting is that the importance for online versus online features for their use case. And finally, Michelangelo and Gigascale. Uber Engineering recently made published a blog post and presentation of their some of the updates that they've made to their feature store. They are kind of the original ones behind the term feature store, and over the last couple of years they've been working on a number of optimizations. And again, some of these requirements that you see on screen are what you would expect: low latency, high throughput, stream personalization, especially when you have millions of users, restaurants, menu items similar to DoorDash, but even having models that are run specifically for a given restaurant. The amount of not just inference, but the amount of possibilities for recommenders is just huge. So Uber and some of these real-time companies share this feature of needing an infrastructure that supports the stream personalization use cases. But the next point and the reason that I chose to feature this use case is that they found that there wasn't a single technology that fitted all of their online requirement needs. So back in 2017, they started with Cassandra for all of their online serving needs. But as part of these optimizations, what they found was that really depending on the use case, depending on the feature set, you could serve those features very well with a simple Java cache running in a single machine. For larger data sets like restaurants that have, it could be in the tens of millions of records, they found Redis super effective for that load. So we're talking, for these tens of billions of users, we're talking hundreds of gigabytes of data. And for their larger feature sets like users, which are in the hundreds of millions and tens of terabytes of data, they stayed with Cassandra. So I guess what I'm trying to highlight here is that at this scale, there is no one single technology that can do it all at the same cost with the same, with meeting all of the requirements. Companies have that choice of building, choosing the right technology for the right feature set. It just adds obviously complexity. But companies like Uber and others at that scale will have the engineering cycles to, the engineering talent to achieve something like this. Another common requirement similar to DoorDash is efficient batch data writes. And, it's about making sure that you can execute large numbers of writes across your online feature store. And again, availability and scalability is another key requirement. So having seen these three use cases, and I'm going to go back to some of those reasons to choose Redis that Guy mentioned. And Redis is a proven technology, and for low latency and high throughput requirements. Sorry about that. For streaming support, as mentioned, this is very important in online feature stores. The ability to have data injection, aggregation, and transformation and storage is super relevant. Support for multiple data structures, and as in the case of DoorDash, and high availability and scalability and cost efficiency. So these are features that you will find with Redis open source. In addition, with our commercial offering, there are a number of additional consideration and additional features that could be part of your decision making. So we support Redis on Flash. So this allows you to offload some of those feature data into Flash as opposed to just keeping them in memory. And for the right use case, this could be, you could strike a good balance of meeting your low latency throughput and storing increasingly larger feature sets. And as Guy mentioned, one of the things that we're more proud of is the global geo distribution capabilities of Redis Enterprise. And if you're not familiar, we allow active passive deployments, which allow you to scale your reads and provide additional scalability, but also we can deploy Redis Enterprise in active configuration. So you can have your clusters for online feature serving in one region completely in active configuration. So dual synchronization between those clusters. You have flexibility of deployments. You can find us on your database cloud provider of choice. And you can also install this on premise or having hybrid deployments, and it's fully supported by the company. So now I want to kind of close this presentation with some of the insights that we think online serving will go in 2022 and beyond. And one of our first kind of insights is that feature store vendors will target this ultra low latency kind of market and in use cases. So far, we've seen examples of end user companies building their own infrastructure, and that is kind of a complex proposition. So we see feature store vendors, developing capabilities to target this ultra low latency requirements. While Feast is not a commercial offering, Feast is leading the way in defining what feature stores look like and the sort of capabilities that they should have. As I mentioned, they published a benchmark last week. I encourage you all to read it. And the TLDR is, Redis won hands down for lower latency. And it is worth mentioning that they compared our Redis open source option. They didn't compare, they didn't include our Redis Enterprise solution there. But when it came to low latency, Redis should be kind of a starting point. Another trends that we expect to see in 2022 and beyond is increased adoption in traditional mass consumer markets. Financial services and fraud detection. I mean, that's the quintessential use case in finance, but with the new world of open banking and new decentralized finance, we see a bunch of other use cases that might demand, they might require the online and real-time capabilities of an online feature store. Media advertising and e-commerce platforms with their endless uses of potential uses of recommenders is another area of growth. But one group of companies that we're starting to see and we expect demand to increase is digital native brands. So these are small companies, injected with a lot of cash and with a huge growth appetite. And not only that, they have a very deep knowledge of their customer base and behavior. In fact, they live and survive because of that capability of to provide extreme personalization and getting driving more customer loyalty, engagement, and differentiation of their service. We expect to see adoption across this segment. And in 2022 and onwards, the importance of low latency is apparent. As we explained, we cover with the case of AT&T, near real-time features is kind of the MVP signal for these models. They encode important user behavior and intent that is needed for real-time applications. And in this segment of ultra low latency, there are companies need to have this latency as the new outage mentality. When latency goes from a single digit to 50 or 70 milliseconds, as Guy was explaining at the beginning, this has a huge knock-on effect on that smooth consumer experience, a customer experience. And not only that, for companies that rely on this, it has a knock-on effect on their behavior. If they can't operate your service at the speed they require, they will go somewhere else. And another thing that is important, as I mentioned, is this geo distribution of your online feature set. In this world, is not having to materialize features when you experience an outage is just not good enough. This might take hours for you to revive your online store, and it's just simply not acceptable. So you need to allow not only for scalability and high availability, but also allow for business continuity. Predictive, real-time predictive applications become part of the service that whatever service you provide. So this is important. And with that, I'll give you back some time.
Excellent stuff. Thank you all. I've been watching the presentation and thinking about different ways that I'm going to weave in some of your keywords into the song that I'm about to sing right now. I was trying to jam on some of it and see if it would work out. So that was awesome. I really appreciate that, Guy and Ed. And there are some questions I should probably, I can ask them before we jump on because it's, we've got a minute. I'll ask one about if there's a common pattern emerging, like using Redis as an online feature store with Feast, or people using just Redis standalone.
I mean, Redis is a store, it's a data store, right? So if you're trying to solve the problem of, your feature store addresses the needs of not just online feature serving, you are, obviously doing your management of features, defining your features, sharing features, all of that good stuff that feature stores do. So think of Redis as the online store, the store for your online feature store, if you will.
Makes sense. All right, fellas. Thank you both for doing this. This was awesome.